Okay, let's just prove that root 2 plus root 3 is irrational. So first, let's prove that root 6 is irrational. So we'll assume root 6 is rational. That implies there exists a p and a q which are both integers and have no common divisor, such that root 6 equals p over q. That would mean 6 equals p squared over q squared, which would mean 6q squared equals p squared, which would mean p squared is a multiple of 6, which means so is p, which means that p is equal to 6n, where n is a natural number. Well, actually, an integer. And then that would mean from star that 6q squared would equal 36n squared, which would mean q squared equals 6n squared, which means q squared is a multiple of 6, which then means so is q, and then that contradicts that the greatest common divisor between p and q is 1. So then that would mean that root 6 is irrational then. Proof by contradiction. Okay, let's prove root 2 plus root 3 is irrational. Assume root 2 plus root 3 is rational. That would mean that there exists a p and a q such that root 2 plus root 3 equals p over q. If I square both sides, I get 2 plus 2 root 6 plus 3 equals p squared over q squared. That would mean that root 6 equals a half p squared over q squared minus 5. That would mean, and that's equal to 2q squared p squared minus 10 q squared, which would mean root 6 can be written as an integer over an integer, which means that root 6 is rational. But this is a contradiction of, let's say, we'll call this line pound symbol. So then that means it was wrong to assume that root 2 plus root 3 is rational. So that would mean root 2 plus root 3 is irrational.